Hey everyone. So in this video we're going to be looking at another ALEKS problem. This one is about writing net ionic equations. So we have this equation here where we have aqueous iron chloride and then aqueous sodium hydroxide forms this solid along with aqueous sodium chloride. So, when we're writing a net ionic equation, the first thing we want to do is we want to split every ion, every cation and anion, along with and note their charges. So what do I mean by that? Let's start with iron here, iron chloride. We know that chloride has a -1 from the periodic table, and we have 3 of them. So we know that in this case we're dealing with iron 3. So when we split this into cations, into its cation and anion, our cation is going to be iron with a 3+ charge, and an aqueous state because we're aqueous, and this chloride, which has a -1 charge, is going to be split into its anion, and notice that there are 3 of them. So this 3 becomes our coefficient. So there's 3 chloride anions. And so continuing to split, we have a 3 coefficient. That 3 coefficient will stay. And this is just going to give us our positive cation for sodium, which is also aqueous. There's 3 of them. And then be careful not to split this into oxygen and hydrogen. That is not correct. This is a polyatomic ion. You should recognize that as a polyatomic ion. This is hydroxide. Now, we know hydroxide has a charge of -1. So we will write that down here. Hydroxide, -1. It is aqueous, and there are 3 of them. Notice this coefficient gets split to both the cation and anion. So that's the left side of our equation. Moving on to the right side. Notice this is solid. When it's solid, it's not being broken up into its ions. You're not going to have Fe3+ floating around in the water, right? It's not aqueous. This is a solid, and it remains a solid in water, so this does not break apart. All right? So we write this, the solid in our equation, we write that just as is when we're writing a net ionic equation. So we write that as FeOH, that is iron hydroxide. There are 3 hydroxides, which makes sense. Just keep in mind that we said earlier that iron has a +3 charge and hydroxide has a -1 charge. So if there's 3 hydroxides, this will be a -3, this will be a +3, they cancel out, and everyone's happy. So, and remember to write your state. This is solid. And now moving on, this is aqueous, so this will be splitting up into its ions. So we're going to be plus, the 3 is going to distribute, and we're going to be left with 3Na aqueous remember your charge, which is +1 for sodium, and 3Cl minus aqueous. So, what we have here is called Complete Ionic Equation. Now, complete ionic equation and net ionic equation are not the same. You often need to you need to write down your complete ionic equation before you can get to your net ionic equation. So how do we get to our net ionic equation? Well, we want to look at both sides of this equation. And what we want to do is we want to remove what are called intermediates. An intermediate is an ion that appears on both sides of the equation. Think of it like algebra, when you have one term on the left side of the equation and another term on the right side of the equation. You can cancel them out if they're, if it's a sum of different terms, you can cancel the terms on either side out. So what I mean by that is notice that 3Cl negative and 3Na positive are found on the left side and on the right side. So what this means is that we can actually just cancel these terms. We don't need to write them. And what happens is we can simplify this without those intermediate terms. And we're going to be left with iron plus 3 plus 3 OH negative, aqueous, reacts to form iron hydroxide, which is solid. We do not write the charges for the solid. It's redundant. It's not necessary because that's not really what we're interested in. Notice the conclusion that we draw from this equation is that we have, in our aqueous solution, remember aqueous typically means it's something dissolved in water. That means in this, imagine a container. In this container filled with water, we're going to have Fe 3 plus floating around and 3 OH floating around, and those are going to combine together and form the precipitate, which will be solid, of FeOH. So these are combining together in the water and forming that solid. And so what you have here, this equation with the intermediates removed, is the net ionic equation. So this is our answer. So one thing, just a quick note, you split up the ions for all the aqueous terms in the equation. You leave the solid as is. You don't write the solid. Only the aqueous term. So if there was a liquid in there, a liquid term, you wouldn't write that. Just the aqueous. We split the aqueous terms into their ions, and we write them all out. We write them all out and that will give us a complete ionic equation. This question is asking for the net ionic equation. We can get the net ionic equation by canceling the intermediate terms, that is, the terms that appear on both sides of the equations, and we are left with the net ionic equation. All right, that'll do it for this video. Thanks for watching.